Focus 9, and we're talking about Venn diagrams. So this can be a little tricky, even though we all pretty much have seen some sort of Venn diagrams before. They basically show an intersection of qualities of two or more things. So our objectives are we're going to be able to create and interpret a Venn diagram. We want to know what the words and, or, and not mean. It sounds easy, but it's a little tricky at times. And we can count. We need to count how many items are in the complement of a set. So Venn diagram, like notice in this region right here, out of all the things that are easy to set up, like maybe a something from IKEA, a table or something. Those are typically follow directions and they're easy to set up. And there are things that can be confusing, like maybe something from math. Math can be confusing. And then in the middle, something that has both qualities, they can be easy to set up, but they can also be confusing. So that in itself would be a Venn diagram. This is like a meta Venn. More examples, and these are kind of silly, but like this is like, a beaver playing a guitar, and this is a duck playing a keyboard, and this is a duck-billed platypus playing a keytar. So a duck-billed platypus has qualities of both, and so does a keytar. And this is kind of funny. When you say it's fine, and when it's actually fine, and there's just a very sliver of that possibility, because when people say it's fine, it's usually not fine. A lot of people that like break into houses, and there are people that leave things behind, and there are people that eat your food. So you can see here, this is like a stoned burglar. Someone breaks into your house and eats your food. Maybe someone who breaks into your house and leaves things behind, that's not a good burglar because they got in but they didn't take anything. Someone that leaves things behind and someone that eats your food, that would be like a first-year roommate in college or something like that, because you got to deal with all the stuff they leave and they eat all your stuff. Then someone who does all three would be Santa Claus. Breaks into your house, he leaves presents, and he eats your cookies. And here's a apocalyptic one. Zombies and aliens. Maybe they have a taste for flesh. And robots and aliens, they have advanced technology. And zombies and robots, there's no emotions. Either way, all three of them together, that's death to humans. This is probably one of my favorite ones because it's people who love incredibly gore horror movies. So there's a whole bunch of people there, and then people who love musicals, and then some people who like both. They're probably serial killers, and that's just a joke, but you get the picture. And then there's people who understand Venn diagrams, people who don't understand Venn diagrams. This is a case where there really can't be an intersection. There can't be a middle spot because these are completely opposite things. You either understand it or you don't. You can't both understand it and not. So that's neat. Hopefully you got a chuckle out of that. And very funny. Okay, so these are some notes, and we have to go over this because some of this is very important. When you make a Venn diagram, and this is probably the most important thing on the slide, you always start with the intersection between the sets. And what that means is anytime you have a number or a number of people or things that fit into both categories, you should add that number into the middle, because that means it fits into both categories and it should be put in the middle, because everything else can kind of fall apart from there, and it makes your life a lot easier. If a total number of items is given, the sum of all individual parts will equal the total, and this includes what's outside of the sets, typically referred to as like the not case, or things that don't fit into either category. So out of all items, there's a Venn diagram. Maybe there's 2 out there, and there's 5 in here and 3 in there, and then X number that fit both. If you add up all 3 of these, that would give you the total number that you're talking about. And then this is interesting, so you may have to bear with me for a second. The word or really means either or for our case. You would be looking for the total number in one event, the other event, or both. And this is tricky because in our language, there are actually two different ors. For instance, let's say you go to a coffee shop and you want to get, they only serve coffee and tea. Okay, so if the server asks you, all right, would you like coffee or tea? Coffee or tea? They're not really implying when they ask you that you would get both. They really are asking you, well, you're going to get one or the other most likely. Which one do you want? That's what the or means. It's exclusive. It means like you're going to get this or you're going to get this. You're not going to get both. Okay, so let's just say you get coffee. Then you would have they come back and the next question would be or whatever. Do you want cream or sugar? And this or is different because it's implied that you could get cream or you could get sugar or you could get both. But really, when we said or and when the server said or in either circumstance, it was the same word or, but it had two different implications, two different like almost hidden meanings. You're either going to get coffee or tea, not both. And then you're going to get cream or sugar, but you could get both. So we have to be careful with this when we see the word or. For us, it means either or. And that means in ours that you could get cream or sugar or both. So you'll see how that plays out in a little bit, but just be careful. It means this one or that one or both. The word and means strictly the intersection. It has to have both. It has to be this X. It has to be that one. If it's and, it fits both criteria. It can't be in this region. It can't be in this region. It has to be in both regions. So and is a lot easier to understand. And then we kind of talked about this a little bit in here. If you're given percents, the total of all sets, like in their numbers, their percents, including the not case, they have to add up to 100%. There's nothing left out of this box. So maybe this is 10%, and then you have a Venn diagram. So like you were saying that 10% of people don't fit into either of these categories, and then maybe 20% are here but not in the middle, and maybe 50% are in this range but not in the middle. That leaves that there are 20% that are in both. Okay, so notice that this full circle right here, that adds up to 70%. So 70% of the people of whatever we're talking about is in this circle. But 20% of those people are also in this circle. Okay, and this circle right here itself is 40%. And then we would see that both we'd also have the 10% that's not. Okay, so like we could, when you add all these up, it looks really crazy. But if you add up all the individual reasons or regions, then we should get 100%. So 10 and 20 and 20 is 50 plus another 50. That's 100. But if you add up the circles, 70 and 40, you're already over 100%. And that shouldn't make any sense. But that's because you double counted that 20. So it's just the individual regions that you'd add up to get that would have to add up to 100%. Okay, that was a lot of words and really boring, so I'm sorry, but it's very important. A lot of different things in this slide. So I'll refer back to it in a minute.